We are in Munich to conduct a series of experiments with our television whitespace devices. We have two broad objectives for the trials in Munich. On the one hand, we are looking at the first trial of our experimental hardware and software in a high-power setting. So, to that end, we want to see how valid our assumptions are about how the software and hardware operate. And on the other hand, we want to investigate the validity of the simulated propagation models that we have been using throughout this project, but in a real-world setting. To conduct the experiments here in Munich, we used two vehicles, one carrying our transmitter and one carrying our receiver. The transmitter car housed an independent power source, from which we were able to run spectrum analyzers and the power amplifier, which housed our cavity filter and gave power to the software radio and the Atos hardware. Connected to that, we had a 10-meter mast, above which we were able to mount an omnidirectional antenna. The receiver was placed in the mobile van. Again, this van had an independent power source, from which we were able to run spectrum analyzers, DVB-T detection equipment, the software radio and the Atos hardware. It had a controllable mast on which we were able to mount directional and omnidirectional antennas for reception. Here in Munich, we have chosen to investigate the operation of these radios in three different environments: in a rural setting, a suburban setting, and in a dense urban setting. We chose these three different scenarios as they test the operational efficiency of our television whitespace device in different types of challenging environments. The TV Whitespace's geolocation database is a key element of the Cogeu system architecture. Cogeu has built a geolocation database for the Munich area with a 200-meter resolution. For a specific TV channel and location, the database provides the whitespace device with the maximum allowed transmit power that won't cause harmful interference with digital TV reception. In this experiment, we have used 30 dBm EIRP. The receiver moves away from the transmitter in steps of 100 meters, 200 meters, 500 meters, 1 kilometer and 2 kilometers. We want to investigate the impact of transmitter to receiver distance on the ability of the receiver to pick up, detect and demodulate the television whitespace signal. We also look at the power level of the power levels received at the different distances from the transmitters in each of these scenarios to see what power level is received at each of these distances and if this agrees with the modelling from our previous work. In the rural scenario, we were operating on the 746 MHz channel and we were receiving DVB-T signals on the adjacent channels both below and above that channel. In this scenario, we investigate whether our television whitespace device has a negative effect on the DVB-T receiver operating on one of those television channels. The suburban trial took place in Freimann, in the northern area of Munich. Munich represents the first time that we have moved outdoors into a high-powered transmission setting, so this has been challenging in terms of evaluating and learning the capabilities of the experimental hardware and software that we are using in the Cogeu project. Our Munich trials could show that the operational distance of whitespace links is also limited by the negative effect of interference coming from digital TV transmitters. So, for 1 watt transmit power, we measured a coverage of 1.2 kilometers for the rural scenario, 350 meters for the suburban scenario, and 200 meters for the dense urban scenario. Taking into account the propagation measurements from the rural, suburban and urban environments, we can confirm that the extended Hatter model may be used for our calculations, particularly for the computation of TV whitespace maps and related safety distances. With the Munich trials, we were able to demonstrate that video transmission over TV whitespace is possible in a realistic setting without unnecessarily interfering with broadcast reception, provided the whitespace device complies with the parameters in the Cogeu database.